Welcome to the video presentation, and I am Ethan Brent Thomas from Group 5, and today we are here to present to you all our documentation from our laboratory exercise. Before we proceed to the main point, allow me to mention some names from my group. Robert Cesar de Dios Jr., Kenji Samoyo, and Adrian Bernardo. So without further ado, let us proceed. So in this laboratory exercise, we were assigned to three different datasets, and our group was assigned to sort out dataset B. Moving on, upon inspecting the contents of the dataset, our team instantly spotted irregular inputs in most of the cells. So which columns are inconsistent? As you can see, most of the inputs do not seem to follow a standard format. For instance, in the cells are displayed as a single letter. Others are fully stated. Prices and delivery fee have similar cases. Both of its contents either state the currency or simply display as a value. This is also the same case for the quantity column. Most cells have the pieces suffix as the value. The rest are simply just values. For the order date column, the cell values are either inputted with the slash or dash in its format. Lastly, for the order time, most of the cells follow a 12-hour time system. This is the AM/PM suffix. On the other hand, most cells follow the military time format, meaning it does not use the AM/PM format and instead uses the 24-hour time system, which should be numeric. First, the prices, because some inputs have the currency stated. Second, the quantity as the word is clearly stated, as the word is clearly stated rather. And third, the delivery fee, which is pretty much the same case as the prices column. Now, what errors may occur during import? Data mismatch is very likely to occur due to its disorganized layout. Even in the perspective of the human, we may not know the contents here and may require clarity for it to be understood. And in addition, during import, there are a couple of errors that may happen if we don't resolve these, and that would be data mismatching. So, for example, in the price and quantity columns, if we immediately import them int or decimal with the parameters 10 and 2, it will fail, as there are words such as the PHP and the pieces. So to resolve this, one simple way is to add a table for raw orders, where every data will be set as varchar, or varchar rather. And once the data has been cleaned, be then adjusted to its supposed data type.
All right, now let's transition to showing the actual file now in the SQL. So what our group did is, of course, we can't really start anything without the database. So also, before I continue, all of these are in separate tabs to better organize. Anyway, to go back to query one. So yes, so first thing we did is create database with food DW set B. And on the next portion, we created the table so you can see the order ID, customer name, gender, city, food name, category, price, and so on and so forth. Now you can see that some of these are already in var character. The reason of that is, of course, earlier we needed to make sure there are no data mistypes. So before we import the actual data, we'll make sure all of these are in varchar first. And you can also see here in raw orders, these are the outcome once you inputted these SQLs. Next is the raw or this is just for me to see the information. Currently, it's actually already in clean data, pero back then it was a mess. Now to go to SQL file for this is actually where we start. Oh, this is where we start cleaning the data. Oh wait, let me put this in the side. So here, we only started off with SQL safe updates. This is only for the reason of to make sure like every time I updated the files, it doesn't mess up or it doesn't destroy anything in the process. Now on after that, we then started fixing some of the issues, which is first of all the gender, where some are like on M, some are on male, F and female. So we made sure that everything will be in male and female. Next is we also removed the wordings in price, in delivery fee, in quantity, to make sure that it would be in numerical order. Next is for the date and format. So for here, since everything was not really in the right order for the date, we made sure it would be, wait, let me double check. It would be on year, month, and day, to better organize. And for the order time, we made sure that everything will be in military time, or where it's like, it's not the AM PM ones. That will be it for the date and time format. And now, since we technically fixed everything, we're ready to import, to like doing the warehousing. But before we do that, of course, we have to return the other data types that were current, which, like, previously on the table it was just varchar, but this time we're here to change them, where prices, instead of it being varchar, it'll be in decimal, quantity will be integer, to just better organize the information in the data. And this is the output of the clean data in SQL file. And what I'll show you now is, this is what the clean data would look like in the Excel file. So you can see it's much more organized. All the genders are female and male. There are no one letters. The prices, there's no more pesos. It's only numerical. Same with quantity and delivery fee. So now, since we're done with cleaning the data types, we can then continue in getting the data warehouse and implementing the dimension tables. So to do so, we need to create first the categories. So the customers, items, all the such. So first thing I did is to create the customer. This is just for me to like show you. This is just to show you how one variable was created. So in customer, we'll need customer ID, customer name, gender, and city. And then I just added the data types for each. And then what I did, usually what you should do is to create the table first, every single one of them, and then insert it afterwards. But since it's not really that much information inside that table, I already inserted it like at the same time, since it won't really be that confusing. And then I also selected the distinct for the customer gender from the raw order. So of course we can't really grab information from nowhere. So it has to be on the raw orders. Next, and then like the rest are basically similar to how I did this. So create table, insert, and then select distinct from raw orders, so forth, so on, so forth. Now the next is creating the fact orders. Now the difference of this one is that I had to separate the table, creating the table and then inserting the data. It's because there's too many information to put, and I believe that if I combine both of them, I might, even me myself would be confused and there might be errors. So I think it's better to separate the two. So what I added here are the order ID, customer ID, food ID, everything that's here in this information here. I just added it here. And also, like, once I added the dimension categories, these tables on the left side showed up. So back then there was none, and then once I clicked the lightning button to run the program, it then showed the rest. And then after I created the table, I then inserted the information from from the raw orders into the table. So I added the customer ID, food ID, and the total amount, which is you have to multiply the quantity and the price, and then add the raw delivery fee. Actually, like everything I've talked about, the dimension on the warehouse, everything is related to here. So to give you a better visualization, I guess. So you can see that there are dimension customer, we have food category, restaurant, date, and time, and all of these are connected to fact order. Now, the reason why there is a lot of variables inside the table is because you'll need these blue icons are the foreign keys, and you needed those foreign keys to connect the other tables, so that uh, to make the system work. So you can see that in the customer ID integer, the it is connected here at the bottom with the dimension customer table. So it goes on, so on so forth, where the customer dimension is connected to the integer ID, uh, co- food to food, category to category, restaurant to restaurant, and that's pretty much it for the star schema. And this all. Now let's go with, actually, yeah, I think that's it. So the first thing we need to do is to find the top 5 selling food items, the top 5 customers, revenue per category, peak order time, and customer segmentation. So yeah, let's start with top 5 selling food items. So yeah, my bad if it takes a while. I have to type it for a moment. Combine in this portion not only the SQL query demonstration but also show you guys the key insights. So what we can see here is that the top 5 starting from the bottom, we have milk tea with 2,893 total sold, fries with 2,938, burger with 2,940, pasta with 2,967, and sushi on top 1 with 3,010. So now that we have the top 5 for this category, let's now go on with, wait, let me find it. The top 5 customers. All right. So now let's also start again from the bottom. We have customer number 887 spending 5,140, customer 2168 5,330, 614 5,950, 663 5,970, and our top one, customer 2,829 with 6,170 total spent. So that's for number 2. Next is number 3, revenue per category. Yeah, okay. Yeah, there is only 4 categories. So we can see here to the revenue for drinks is 993,360. Asian with 1,067,000, well, 6,700. Western with 1,000,000, uh how much 102, wait, 1,000,000. How many is that? 1 2 3 1 2 3 my bad. 1,028,610 and 1,038,040 revenue for fast food, which is the highest one out of them all. Now for number 4, we have peak order time. But yeah, these are overall, but let's go with the top 5. Top 1 with 7 as 395, 22 for 373 order count, 11 for 371, 12 for 362 count, and order R 21 with 361. Now, let's go with the last one. We have customer segmentation. Oh, that's a lot. Okay, bear with me. So now, this is the last one for customer segmentation. We can see here that I think majority here is just high spender. But yeah, this is the answer for the fifth question. But yeah, there's I think a lot of them are just high spender. At the very down. Yeah. But anyway, that is pretty much it for this presentation.